You know, when you're in love, the whole world is an engineer. That's Mark Yamamoto. This is Hawaii, the state of clean energy. That's Ray Starling. And Ray and I have the joy of talking to Mark today. He's a real live 100% engineer from Hawaiian Electric. You know, how rare, how wonderful to have him here with us. Thank you, Mark.
Well, thank you, Jay. And thank you, Ray.
Yeah.
It's good to have you today.
Great. We have a million questions. Let's see how many questions we
So
have.
we,
I think this is a 6-hour
when
show.
we have an engineer who's got some gray hair, we usually expect them to bring their slide rule, K&E slide rule. You remember those things?
Oh, yeah. Yep. Yep.
Yeah, now it's in your cell phone, hey?
Yeah, wasn't that how the Apollos were built? Slide rules, yeah.
So it's actually, it's Customer Solutions Engineering
Director.
Director of.
Yeah.
Okay, what is that exactly?
Well, what we do is we provide technical solutions that we can bring back to the customer, residential and commercial, industrial, that can provide them some benefits, especially in the realm of cost savings.
Especially. Well put in these days.
Yes.
You know, so I was casting about for, you know, some name for the episode, and you're going to enjoy this, Ray, and I decided to call it bidirectional is the word of the day.
Bidirectional.
Yeah. We have to, you know, if you guys haven't studied engineering as it relates to clean energy, you got to know the word bidirectional. It's all about, there's lots of other words too, don't get me wrong, but bidirectional, to me, you know, is the part that everybody has to understand. It's not like a Christmas tree where you hang the photovoltaic units off the branches every Christmas and see how many you can hang on the branches of the Christmas tree. Not like that. It's different.
Okay.
You got to build it 2 ways.
That's correct.
So how do you do that?
Mm-hmm. Well, that's a good question. And yes, bidirectional, it's all about a shifting paradigm as we move towards the road of, you know, towards the goal of 100% renewable energy by year 2045 as mandated by law now.
Ray and I have both sworn that we're going to live that long. We're going to be there for I can hear the champagne corks popping now. And they're going to drag that last fossil car off the street, driver kicking and screaming. You'll see. Right. Never mind, sorry.
Okay. So there are, of course, a lot of customer benefits for that, and as well as environmental benefits. The whole point about us being off of fossil fuel by that time does not come without technical challenges, of course. A lot of these systems for rooftop solar, well, all of them are based on inverter technology, inverter-based, meaning these are essentially they're DC to AC converters that have these very fast switches in them, electronic switches, and they present some technical challenges that we have to deal with.
But they're getting better, right?
Oh yeah.
I mean,
yeah,
you know, if you're looking for one area in the new world of clean energy that has where the technology is moving right in front of your eyes, it's in inverters, isn't it?
Yes, and that's the thing is that Hawaii is really on the leading edge in terms of the nation, and we have some lessons learned from places like Germany and Australia, New Zealand. Some people call it the bleeding edge, but we refer to it as the leading
We should
edge.
teach them, though. We should.
Oh yeah.
We want them to learn from us because we're smarter.
Yes. Well, more akamai.
Thank you.
Yes.
There you go.
And definitely, there's this whole advanced inverter piece that's coming together right now to deal with a lot of these challenges. A lot of things that incorporate autonomous controls into them. Things that have some grid support features, and you know, a lot of it is in support of the future envisioned smart grid, as well as, you know, of course, to to help customers with their envisioned plans of interconnection to the grid on the DER side. Yeah, bi-directional.
Yeah, let me have a conversation with the control room. Zuri, have you got sound? Okay. Better we should ask, not ask.
She would have
It's an
thrown something at
engineering
you.
question. Okay, so we start out with the inverter that just converts DC to AC. That's it.
Mm-hmm.
And then you're adding all this new technology on it. And one of them, let's see, what are the technologies that are in play these days, the ones that are exciting everybody about inverters?
Well, it's inverters in conjunction with energy storage, for example. Energy storage, and is it, we've gone through this process under the Distributed Energy Resources, or DER docket, that's in play right now with the Public Utilities Commission. Other stakeholders are involved in it. And there's this idea of, in some cases, it's grid supply, and in some cases, it's self-supply. So the self-supply piece, of course, has to do with energy storage of all of that solar energy converted to AC, and in some cases, I'm not sure if it would be completely DC to DC, or does it take DC to AC and AC to DC conversion once again to store that energy? But certainly there's things there for that we have to look for in terms of storing all of that, what would be excess energy during midday that we just don't have the load to support all of that. It has to go somewhere.
So that's where the smart grid, at least in part, lives, in the inverter. It reminds me of my partner. He bought a thermos one day, thermos?
Yes.
And he put it on his desk, and I caught him looking at it. He was looking so focused, and he said to me, how can it tell?
How can it tell?
It keeps the hot, hot, and the cold, cold. How can it tell? And there's no answer. It's a conundrum. But
not for an engineer.
Not for an
engineer.
So the question I would put to you, actually, Mark, is how can it tell whether to send it this way or send it that way?
Right. And, so there are things in there that in these pieces of equipment, these components that, there's some sensing technology, there's controls, and of course, the things behind the controls that are the smarts that perform all these algorithms and
right inside the
software.
inverter. This is autonomous in the fullest sense. It is doing the intelligence right there.
And on the grid side, what we're looking for is more visibility. We want to be able to see what's going on with all of this distributed energy.
So you want to look at the inverter, through the inverter, and find out what's the situation.
Right.
Let me ask you a question about that, if you don't mind. One of the things that you want is to see what's happening on a particular inverter, and was wondering what are you looking at now as more and more of these inverters are on your grid, basically, and you want them to act properly, and you also want to be able to understand which direction the flow is going. What do you have any plans now to actually gather that data from either new systems or old systems, or retrofit old systems, to gather that data for purposes of kind of knowing what's happening with those inverters? Because right now it's not apparent on a particular solar panel what's happening, whether it's absorbing energy from the grid or pushing energy out to the grid.
Before you answer that question, I'm going to take a short break, okay? Mark
Okay.
Yamamoto, Ray Starling, short break.
All right.
Aloha, my name is Jim Sean, and I'm host of a show called Education Movers, Shakers, and Reformers. Each week, live streaming at noon on ThinkTech Hawaii, we interview people who have special insights into education from early education through K-12, all the way through higher education and beyond. Both public and private are areas we're interested in. We dig deeper. We try to find out what it's really like to be involved in making change, advocating for it, how you reform, what people's philosophies are in reforming it. As I said, we're live streaming every Wednesday at noon on ThinkTech Hawaii. And later on, you can find these interviews on YouTube and on the Hawaii Educational Policy Center website. We hope you join us as many times as possible.
Well,
Oh, okay, okay.
Okay, we're back, we're live, we always have a great time during the breaks. And Ray was restating the question during the break, and I said, well, wait a minute. How about now? Restate the
Okay.
question now.
The question is, you have these inverters on your system, and they're doing whatever they're doing, and you don't control those. They just path of least resistance, I guess. And when the sun's shining, there's excess power, and it goes out onto your grid. So I was wondering, what are you doing to try to understand what's going on with the actual inverters? Is there some plan to sort of make people in the future have to report the data or give you access to that data, or is that something you can retrofit? Because it seems at some point you really have to know what's going on there.
Yes, and that's a very good question, and we actually are working with a few vendors, manufacturers, to develop, these user interfaces for our operators. I think that's a good step in the right direction, especially if we're working with maybe the top one or two of these inverter manufacturers, and they have already the capability to get visibility into how much power is being produced by PV systems. And when it comes down to the operations level, I don't think our operators want to see every single home or business, they want to see some kind of aggregate
Yes, yes.
portion of the power, maybe in regions, maybe on circuits or whatever it may be. They want to see what's happening, and they want to be able to react fast enough to whatever conditions that they would probably have certain types of conditions where they would have to react somehow. And the other part is working with these manufacturers, vendors, to develop maybe autonomous type of algorithms where we can go in and maybe set some parameters and just maybe download them based on some maybe seasonality, maybe on the particular circuits, whatever it may be. Where this is leading, I think, is at some point we're going to have to come up with a way to aggregate all of these on a common type of, for example, communications protocol that works with, is interoperable with our smart grid.
This is such an important discussion, As we've been dancing around this for years, and here's a guy who can tell us actually how it works. So I have 1,000 questions. I wasn't kidding about the six-hour show. So first of all, I put in my PV 2 years ago in the blush, okay? It's 2 years old. The inverter is 2 years old. It doesn't have any of this new stuff on it. What happens to me? I'm left behind. What happens to me?
At some point, I would think that there are going to be some failures, repairs being made, and we're trying to work with the stakeholders in the DER docket to come up with a plan. So what happens at that point? At that boundary condition where a customer, hey, I need to upgrade my system. I think at that point, there would be a move to, okay, when you upgrade it, you're gonna have to upgrade it with the right thing.
It sounds like cable TV.
Yeah.
You know what I mean? I mean, it hasn't happened to me, but I understand one of these days I'm gonna get a new box in the mail, and I have to put my old box in the box and send it back to them. This is what they tell me. Okay, so what's happening there is the Oceanic Cable is dealing with some box manufacturer, and that's who makes the box. That's it. And I get that in the mail, and I use that because that's the only way I'm going to get the signal. Okay, and when the next revolution happens, or the incremental increase in the technology for the box happens, I'll get another box. And the box is not, I don't own the box. I didn't pay for I'm paying for the box every month, but I don't own the box. The box is theirs, okay? What about that as a model, Mark? Why don't you own the box? And when it's time to change the box, and I mean something that wraps around all the inverters in my house that talks to them, and if they're not smart enough to listen, we get better ones. But it's your bag to make sure that you're getting the right data, you're sending the right data, and you don't have to deal with some third-party box that doesn't work for you.
Right. And that could be a model. Another one could be, and this is already happening, there's some local installers who are actually putting in these interfaces, and it's called AC coupling. They actually put in these boxes with the right kinds of sensors and the right kind of connectivity, so that there is some visibility that at some point in the future can go back maybe to the utility, and there's also some control to modulate that power, provide other kinds of. Here's a big electrical engineering term: reactive power. So
I'm
there's
not changing the name of the show.
reactive power
The
and
show is
reactive
still
power.
bidirectional is the word
Yes.
today.
And I'll give you an example. Air conditioning. Everybody thinks, wow, if I put a big enough battery, I can go off grid. But I love my, 3-ton central air conditioning unit. And to start that up, and here's how a non-techie can tell. When you hear your air conditioner compressor kick on, or even if you use a hair dryer, for example, look at the lights. What do you see? You see them dim for a flicker for a short moment. That's reactive power. It takes a lot of oomph, a lot of current to get that piece of machinery moving, because not everything works in electronics. There's still a lot of motors and such. Does it make sense to put a huge battery system to take care of that split second when you need to start something up like that, some machinery up, or does it take something else, a smart capacitor bank or something to provide that?
What surprises me about this is that I would have thought that there was a box, call it the SJ67 box. I made that up. That's manufactured in Minneapolis, that it's perfected, used all around the country. And you have one on your desk and you're looking at it and you think that might be the answer to bidirectionalism here. But it doesn't sound like you've settled on anything yet. You sound like you're still looking at this, looking at that, not clear about what input, what output. It sounds like we got a way to go before we get to where you want to be, Mark.
Yes, things are still being developed. And, there's the whole process of the thing about there's development, there's bringing it to production, there's the scalability of it. What's the next step? Can it be produced in a scalable fashion that it becomes affordable? And then, the whole Six Sigma cycle of at the next point we have to maybe recalibrate things. And that's how we see inverter-based PV. At some point, it's going to have to be recalibrated, make adjustments, and then go back to production again and continue that cycle.
Could you design one?
could I design one?
Oh, so, you know, I remember going to one of those startups in Manoa Innovation Center, and by gum, those guys were making electronic boxes, and I thought it was really sophisticated, autonomous kind of artificial intelligence, well-programmed boxes that could be reprogrammed remotely. Okay, I mean, just exactly what we need, and it was right here. It was right here in River City. Could you design that? Could you talk to some guy at Manoa Innovation Center and say, make me a prototype, and then have it manufactured somewhere deep in Nepal?
You know, that's
I'm
a,
only kidding
you
about
know,
Nepal.
that's a good question because, you know, actually, the folks that we are working with, they're, you know, and we're under NDA, so I can't mention exactly who, but one of them is a local company, and you know, and there's other folks like, for example, within the Energy Accelerator program, which actually has to do with Victor and HMEI, all of those folks too. They are, you know, developing prototypes of these. What we do, you know, we actually have a test facility at one of our plants actually. And we're putting it in the test bed, and we're going through trying to evaluate a lot of this technology. So part of it is to establish the right protocol so that we know that we're in line, for example, with what's going on in California, Rule 21 with the California Commission, with all the rooftop solar that they have to deal with over there. Smart Inverter Working Group there. And
You know, I remember we took a trip to Kauai one time, the Energy Policy Forum, and we talked to Yamani.
yeah,
Yamani. I want to say Steve Yamani, Mike Yamani, yeah. And you know, with the issue, and also Ben Sullivan there, and the issue there, there's a lot of issues because some people think that black boxes are invasive into their private family shtick, which is ridiculous. Sorry, but they didn't want them in their house, and there was a vote actually, and I think there's even an opt-out arrangement in Kauai.
That's correct.
But what's interesting is that they had a specific box, and I think they got something in place right now with their box in their house. I mean, should they not opt out, is talking to the utility and sending information. Is that available here? Is that available in the Hawaiian Electric part of the state? Is that something that we could use in the Hawaiian Electric part of the state?
I think it's not a could, it's we shall use, because we need that. We need this advanced metering infrastructure to move forward. And, you know, we have a pilot right now. It's, you know, pretty small scale. It's maybe 5,000 customers or so. And all of that is getting sussed out. And how do these inverters, for example, can they piggyback on that network? Is there a way to do that? Or do they go on their own and somehow everything gets backhauled into a system where it gets picked up by our operators? We all speak, you know, the same language. It's fast, it's secure. That's a big thing. We don't want, you know, people hacking into this network where, you know, it's customer information. Number one, there's the revenue piece of it. It's revenue meters. And then the other point is that, of course, just imagine if somebody got in there and started, you know, shutting down, you know, entire blocks of these, you know, especially this our
neighborhoods.
great customer like the DoD, for example.
Yeah.
You know, we wouldn't want that to happen. So it has to be secure. You know, it has to comport to the right communications protocol, for example. So that's the thing that we're really working very hard to come together on, you know, within our company and also with stakeholders, you know, so that everybody is on the same page. I think everybody, it's a given, we're going to move towards that goal, that lofty goal, but at the same time, it's not without challenges, and we all have to kind of, you know.
So what's between here and there? I mean, what challenges would you say right now, the ones you're looking at? And when would you say that I'll be able to get my box in the mail?
It's, working through the regulatory process, to make sure that we dot the i's, cross the t's.
You mean the PUC has to approve of the box?
Oh, yes. They have to approve of, moving forward with beyond the pilot stage, so
Wow.
that this is.
They don't have to approve of our studio lights, do they? I just want to be clear about this thing. That's a lot of approval, isn't it, for them to approve your black box?
There's a lot of things in play. And, and again, it's not all distributed energy, the rooftop solar, for example. It's things like in Ray's space, the, energy efficiency. That's on board so that they see that, still water heating is a big part of my electric bill.
Sure.
And that's a really affordable and tested technology that people can get on board with, that they don't have to put up a huge array of solar, photovoltaic solar.
Yeah.
They can also partition out some of the roof for.
Before we go to our next break, let me see if I can kind of do a schematic in my mind, which is not an engineering mind at all. So this inverter box gets information.
Mm-hmm.
It gets information from what time of day it is, I suppose. Information from what load right now we have in the house. Maybe it could be, very parsed out so you know what part of the house is creating what load. It gets information as to whether there's any battery operating at any point in this continuum. And it sends that information, or it allows access to that information to Hawaiian Electric, either directly in a central place or through intermediate steps, where the sort of information is gathered and then made available on a batched basis to the head office, so to speak. And then the head office can make some electronic decisions, some programming algorithms to say, well, we are going to, like what? We're going to send him power, we're going to take power, we're going to have this, what's the word, bi-directional experience in one degree or another. And it's going to actually talk to the black box and give instructions to the black box. Is that where we're going? Is that what we're talking about?
I think it's going to go beyond that. Right now, one of the issues, for example, is voltage. That the more generation that you have on what was traditionally the load side, the end of the grid, customer side, and then it's competing with the generation side, the grid side. What happens is that what was designed to go unidirectionally is now bidirectional, and you have voltage issues, typically high voltage during midday at a maybe a cluster of customers who have photovoltaic, nice sunny day. All of a sudden the voltage rises above what we call our tariff settings of or thresholds of plus and minus 2%. Typically that means for a 120 volt system, 126 volts. It starts creeping up over that. And what then happens is a lot of these inverters will trip off. They'll just shut themselves off because they're programmed
as
that
a
way.
safety factor.
As a safety factor.
Yeah.
So that's one of the things that, if there's a way to control the output of the inverter, maybe autonomously, whether it's real power or active power, or it's that thing I call reactive power, then it can actually bring the voltage down at that endpoint.
Like transform it down.
Right. Or in a way modulate it down. That it
With a high-tech,
yeah.
effectively a high-tech transformer.
Something that's built into the transformer, into the inverter that way.
That's an inverter
Yeah.
that's not on the market.
And no, it is actually.
Okay.
And that's one of the things, including frequency, that we're working with inverter manufacturers on. In fact, that's one of the conditions to get interconnected. It has to have these, what we call frequency and voltage right through in trip settings. And, you know, I don't want to go into the details of it, but it's on our HawaiianElectric.com website. And the folks who really dig in there and look at it almost every day, every week, are the vendors, the folks who install these systems, because it's their bread and butter. They know that these systems, to get approved and, you know, for interconnection, have to meet these certain settings. So they're doing that. So those are the things that it's already there. Now it's taking it to the next.
That's why it's so
level.
appealing to think that you could get a black box SJ67 out of Minneapolis that will do everything that Hawaiian Electric feels ought to be done, and say to the homeowner or whoever is providing, you know, is in this bi-directional relationship, use the black box, because then we'll know what you got. We'll have the right information, you'll have the right, transformer capability, and we'll all be, to use your term, on the same page.
Yes.
So, I mean, really, I agree with you, but it's a matter of getting uniformity. And once we achieve uniformity, the customer doesn't need to be concerned with any of this because it's all automated, and B, neither does the installer. He just puts that SJ67 right in there. You can use my number if you like. You know, and I'm sure that Ray has either rebuttal or further questions on this, which we're going to get to right after this next break. Are you ready, Mark?
I'm ready.
He's ready. Good. Mark Yamamoto, Customer Solutions Engineering Division, the Director at Hawaiian Electric, here on Hawaii, the state of clean energy. Bidirectional is the word of the day. We'll be right back.
Aloha. I'm Grassroots Institute and host a weekly program, ThinkTech Hawaii Broadcast Network. Hanakako means let's work together. Think of the sad alternative, let's not work together. Here in Hawaii, with all of our diversity and the richness of the people, it's important for us to come together around issues on the basis of what's right and what's good and what's going to serve the common good. And that's what we try to do at Hanakako. Every week we interview movers and shakers, people in government, business, and other sectors of society to talk about how to create together a better government, economy, a better world here in Hawaii that can bless the rest of the world. I thank you for your attention to ThinkTech Hawaii, and we look forward to seeing you every Monday, 2 to 3 p.m. on the ThinkTech Hawaii Broadcast Network. We're Ehana Kako, and we wish you well. Aloha.
Okay, we're back. We're live. We're here with Mark Yamamoto of Hawaiian Electric and Ray Starling. In Hawaii, the state of clean energy and bidirectional is the word of the day, but it's only one of the words of the day. There's another word. And when I asked Ray if he would pursue or be interested in pursuing the panel issue, he said no.
No, I think the panels are moving along. There's been a lot of breakthroughs, technical and otherwise, that have really made panels come alive again, and I think we're doing a good job. But I am concerned, as an electric vehicle driver, I am concerned and was thrilled to see Hawaiian Electric was going to install quite a few of the 440 volt direct current chargers.
Yes.
I think they're called type 3.
Well, we call them DC fast chargers.
DC fast chargers.
Yeah,
All
DC
right,
fast
but
chargers.
that to an EV driver who occasionally has a little range anxiety, especially if you're driving one that's got 3 or 4 years on it. So I'm interested. Could you tell us a little more about what you're doing in the EV area?
Sure. So infrastructure is one area, and as you mentioned, we actually have a tariff where we are allowed to install up to 25 of these DC fast chargers by you know, up to and perhaps beyond 2018. Right now, we just installed the first one out at Dole Plantation,
Yeah.
and that was great. And that was the end of June. Is it end of June or yeah?
Is it popular?
Actually, we're getting quite a few charges during the day. Typically, maybe one so far, but we hope that that goes up as more people hear about it and they feel that it can alleviate range anxiety, as Ray brings up.
Yeah. How does that work? If I wanted to go charge my car, drive up to it, do I call somebody? Do I punch in on my iPad? Do I swipe a credit card, or is there something special to get the charge that you need?
No, it's a credit card.
Credit card,
And
okay.
I think we actually have our rates up on the charger. So if you charge during what's called the off-peak, it's I think it's $6 for a session. If you charge during what's called the mid-peak, it's $6.50, and if you charge during the on-peak, then it becomes $7. Now, what we just did was we said, you know, this whole idea of 3 periods, 2 periods for, we call it time of use. We just filed a new proposal to the commission, asking for, you know, approval, so that we say we'd like to change everything so that we just have two periods, so make it simple for the end user, for the customer, so that, you know, instead of, oh, is it 3 periods or is it 2 for this one? So that's one thing. And once if we get that approved, then we can move into changing the rates for the DC fast chargers. So we only have one so far, but most people, when they charge it, it's at $6.50 per session. And again, credit card swipe. Usually people go in when the battery is, you know, pretty low, and a lot of EV drivers by now are pretty akamai. They read their bars. If you have a Nissan Leaf, and they can figure out, okay, I need to get this much more if I need to get to La Ye, for example, and they'll do that. We kind of strategically chose Dole to be the first one because it is
It's out in the middle of
it's the
nowhere.
pico,
Nowhere.
actually. It's the center
Yeah.
of
Oh,
the
I
island.
didn't realize
And
that. Yeah,
you know that
right.
if you're going which way from east to the North Shore, there it is, available for you. The other thing, that interesting thing that I found out was at Dole Plantation is they say it's the most visited tourist attraction.
Outside of Waikiki.
Yeah. Well, yeah, outside of Waikiki.
Yeah.
And so you know, you mentioned what is the update? One Sunday recently, we had 3, so that was a banner day for us when we got 3 sessions out of that.
All right.
We can tell just by the, you know, again, I'm showing my engineering nerdiness. We can tell by the profile of the charging pretty much what kind of car it is, because now you have
Sure.
Nissan Leafs that can use it. By the way, it has both kinds of charger outlets.
Oh,
It
really?
has
Good.
CHAdeMO and what's
Yeah,
called the SAE combo plug
Right,
as well.
right.
It has both plugs. They cannot be used simultaneously, by the way, but we can tell if it's Leaf or if it's i3, BMW i3,
Right,
for
right.
example. So, you know, really interesting stuff that the kind of data that we can pull from this pilot that we're doing.
Will it service a hydrogen car?
No.
I mean, but a hydrogen car is feeding a battery.
Right.
No, well, it's feeding a fuel cell.
Yeah, so a fuel cell, so
But
it's
the
hydrogen.
The fuel cell is generating electricity for the battery
No, well, it generates electricity.
that goes in a battery.
No, it goes straight to the motor on the.
Are you
on
sure?
the
Are you
drive-
sure about this?
Well, now,
We're gonna
we'll
come
have
back to this
Stan
issue
Osserman.
later.
We're gonna bring Stan Osserman back.
But you
for
see,
the-
if I'm right, I'm not,
If you're
I'm
right,
not
okay.
totally right,
All
you know,
right.
confident, but if I'm right, and there's a battery in a hydrogen car, you could have a third kind of connector and also feed the hydrogen car. Then you cover the whole gamut.
But see, they sell electricity,
Yeah.
so.
Not hydrogen. I
Not
know.
hydrogen.
No, but I'm talking about
Okay.
electricity for the battery in the
Oh,
hydrogen
okay,
car.
right.
But going to that same point, you had to go to the PUC to get permission for what, 25 charging
Up
stations?
to 25.
Up to
right.
25. And you put in some, how many so far?
We put in one.
Put in one.
And we hope to put in 2 to 3 by the end of this year.
Okay, and they're gonna also be a dole, they're gonna be spread
Oh,
around?
they'll be spread
They'll
out.
spread around.
We want to make it sure, we want to make sure that it's done strategically, that, with the
Absolutely.
costs involved, they're not cheap. I gotta say it.
Suppose, this is a multiple issue question, fair warning. Suppose I wanna make a buck.
Mhm.
I'm a nonprofit and I don't usually wanna make a buck. But suppose I wanna make a buck in the charging station business. Suppose I wanna compete with Hawaiian Electric.
Mhm.
Suppose I build little charging stations, really tiny design charge, and I get an electrician to help me, wire 220 or whatever, 440, whatever it takes, okay, to my charging stations. And in lots of locations, all around. So Ray never has a moment of anxiety again, ever. Okay, all over the island, okay? 100 of them, okay? And it's gonna cost me a lot of money, I know that. But I'm gonna put them in strategic locations. And where you charge $6.50, I'm gonna charge $16.50, because there's no reason I can't do that. But my question is, in order to do my 100 stations at $16.50 and 440 fast charging, make Ray happier than he's ever been, okay, do I have to get PUC approval too?
I don't know, you wouldn't have to, because you're not a regulated utility like we are. This is
Be a
all about.
customer.
Yeah.
You just be a customer.
Yeah.
You buy power and then
Mhm.
resell it, I guess.
That's
Oh,
one
wow,
of,
that's,
that's one of the things that we had to do
Yeah,
when we
that's-
filed for that. We had to change one of our rules to say, for electric vehicle charging, you are allowed to resell
Yeah.
electricity, only in that case.
yeah.
And, we look at it this way, we support electric vehicles as a clean transportation. clean
Really
form of
important, yeah.
transportation. And, if there's a way, for example, to increase the midday load so that we take care of this duck curve issue, the whole thing about excess generation during midday, we're all for that. If other folks want to get into the marketplace and, really just, put all of this public charging infrastructure out there so that EV drivers are happy, that's fine by us, because we support that. We want to find a way for everybody to win in this. And, that what's happening is that the industry is finding it's a tough sell. It's not cheap. If you go into a multifamily dwelling building, where and you want to start, especially in the retrofit situation, you want to start putting in some electric vehicle charging infrastructure. Folks come back to us and say, "Gosh, it's tough. It's hard." Because you have to deal with, associations and so forth in the building, and
Sharon Moriwaki, if she were here,
Yeah.
she would tell us the story of her own
Yeah.
association. Well, maybe she wouldn't tell us the story of her own association,
But-
but it was plenty of
Yeah.
effort.
And those are the things that, other than just, here's our pilot project that we get involved with as well. It's the rate making, time of use, rates for electric vehicles, as well as, the outreach and working with stakeholders like building owners and such, looking at things like workplace charging and charging within these multifamily dwellings, because otherwise, if you think about it, where is the market for electric vehicles? It's basically single-family home owners who can just say, I just want to do it. I'm going to do it. I'm going to get an EV, and
That's what
I'm
you
going to
have.
plug it
huh?
in.
You
that's
put
what
it
I
in
did.
yourself at home, yeah?
Well, I had it installed.
Oh, well, of course, yeah.
Yes.
Is it a 220,
It's a
a
220,
440, an
right.
880?
It's 220. But actually, you know, I was one of the first to do this, and they actually required you to put in a charger. Although a charger for a 110 outlet comes with the lead.
It takes all night, though.
But you're gonna sleep through it, right? You plug it in. Had I really thought about it and known about it, of course, they didn't give us a choice, but nowadays you can buy and you don't have to put in a 220 charger. And for those who just come home, plug it in, whether it's 2 hours or 4 hours to charge, who cares? You're eating dinner and going to sleep.
Yeah.
So it's actually, it's a little easier now than it was when we first got started, but we've learned a lot. And, you know,
Well,
I'm proud of you guys for doing what you're doing.
We're at the point of the show where we always, not always, but lots of the time, we offer you, Mark, the opportunity to speak to our public, and tell them whatever message you want to leave with them about, you know, about customer solutions at Hawaiian Electric or anything. So why don't you look at camera number 3?
Oh, 2.
No, 3. Wait, 2. Okay.
Well, thank you. Thank you again, Jay, and thank you, Ray, for having me here. And, you know, if there's one thing I want to leave is that, leave folks with is that this road to clean energy, again, it's not without its technical challenges, and we offer at Hawaiian Electric Company customer solutions based on technology that, you know, will help the customer along this road to clean energy. It's, you know, it's there's a lot of technology involved, but we're looking at things that, you know, to do the hard work so that maybe the final product, the final solution is transparent to the customer, and it helps them to save money. You know, it reduces their electric bill. That's the bottom line. I think a lot of folks do a lot of these things. So, you know, there's a whole goal of the environmental aspect. But I think, you know, when it comes down to it, dollars and cents, people want cheap electricity, and they want, you know, they want solutions, and they want it pretty quick. So we're trying to struggle with that. And again, we're in it to the end.
Yeah.
Good.
Well, when I look at the lights, you know, and I notice that they're still on, I think of Hawaiian Electric, you know. I mean, reliability is so important. We take so much for granted in that department. But when I think of Hawaiian Electric in that context, Mark, I think of you.
Well,
I think of the engineers, because you're the guys who keep them on.
Yeah, and I think about the guys in that bucket truck. You know, when the chips are down, when it's pouring rain. I think we might have squeaked through
Hurricane.
Yeah.
Yeah, good work. Well, you made a call. What happened?
Yeah. But you know, I look at what happened on the Big Island last year with Isel.
Yeah.
And when the chips were down, the guys out in the field really pulled through, and it was, you know, and the community too as well.
Yeah, that was a great demonstration. What do you say, Ray? You want to summarize?
Well, I think there's a lot going on, the solar panels and how HECO is handling that as it continues to grow, and they are handling it because they are allowing more solar on the grid now. And I know there's a lot more that you're in need of doing, and we wish you the best, and we do want you to come back and talk to us.
Oh, okay.
And we've got some more questions about the electric vehicle charging stations, because that's a big interest item right now, and I'm so glad to see you guys getting out there and really putting a number of good chargers in place. So more power to you.
More power to you. Wow, why didn't I think of that? Okay, Mark Yamamoto, Customer Solutions Engineering Division Director at HECO, Hawaiian Electric, and here on Hawaii, the State of Clean Energy. Me and Ray Starling talking about bidirectional and much more. Thank you so much, Mark.
Thank you.
Thank you, Mark.